Here we have a circle inside of a square, and square has a length of 1. And we're looking for AP, or the length of it. And AP is right there. To begin with, let's create or draw this right triangle, and we're going to label this point N, where the length of NM across is going to be 1, since the length of the side is 1, side of the square is 1. And the length of NA is going to be 1/2, since it's half the size or side of the length of the square. Then, since this is right angle right here, we have a right triangle. So let's go ahead and use the Pythagorean theorem to find the value of, or the length of AM, from AM all the way across, where it's going to be AM squared, since AM is the hypotenuse, equals 1/2 square plus the other leg, or 1 squared. And if you solve for AM in this equation, you'll end up with AM equals √5/2. Next, let's go ahead and draw this line NP and draw this line PM to find this angle here, angle NPM. But to do that, we need a formula or a theorem called inscribed angle theorem. What it is that if the measure of the arc is 2A, then the inscribed angle here will be A, or half of the measure of the arc. Remember, this is half of the circle, which means that it has an arc measure of 180 degrees, which means the inscribed angle here is going to be half of 180, or 90 degrees. So we now have a right triangle here on the right. Also, AM is √5/2, and if we let AP, what we're looking for, be X, then the length from P to M will be √5/2 minus X. And if we go ahead and highlight the hypotenuse of this red triangle on the right, we can now use the Pythagorean theorem to set up this equation where √5/2 minus X, meaning the leg, the base leg of that right triangle, square, plus the other leg, which is NP square, equals 1 square, or the hypotenuse. Let's just go ahead and take this expression, bring it to the right side, where we could set the equation NP square equals 1 minus that expression right there. Alrighty, moving on. Then we now have the triangle on the left, where if we highlight the blue triangle on the left right here, once again, using the Pythagorean theorem, meaning this triangle here. Using the Pythagorean theorem, we have x squared, the base of the triangle, plus NP, which is this, square, equals the hypotenuse, or 1/2 square. In order to isolate the NP square, we're going to bring the x squared to the right side, where we have NP square equals 1/2 square minus x square. Alrighty, now notice that we have NP square equals this, and we have NP square equals 1/2 square minus x square. Since they both equal NP square, we could go ahead and set them equal to each other and make an equation where we have just the x. Now we can go ahead and simplify this expression and solve for the value of x, which of course is the length of AP. To solve for x from this equation, let's go ahead and do this on the side, where we have √5/2 minus x times √5/2 minus x, where √5/2 times √5/2 is going to be 5/4, and then √5/2 times negative x is negative √5/2x, and then negative x times √5/2 is again negative √5/2x, and finally negative x times negative x is plus x squared. So then we'll take this, well, before we take it actually, let's go ahead and simplify one more step where we combine these two, where we have negative 5 over 2x minus 5 over 2x is going to be minus root 5x plus x squared. Now, let's go ahead and take this, replace that in the parentheses, where it's going to be 1 minus 5 over 4 minus root 5x plus x squared. Next, take that negative, distribute it into the parentheses. Notice that we have negative x squared on the left, negative x squared on the right. So we could go ahead and cancel these two off. And then 1 minus 5 over 4 is negative 1 over 4. And then we have the rest, or plus root 5x equals 1 over 4 on the right. Then we'll go ahead and add 1 over 4 on the right and 1 over 4 on the left and the right, where we end up with root 5x equals 1/2. Finally, we'll go ahead and multiply by 1 over root 5 on the left and 1 over root 5 on the right in order to get rid of that root 5 on the left. So we end up with x equals 1 over to root 5. If you want to get rid of that root 5, meaning rationalize the denominator, we want to multiply by root 5 on the top and the bottom, where 1 times root 5, of course, is root 5. Root 5 times root 5 is 5, and then if we go 5 times 2 equals 10. There you go. This, or root 5 over 10, is going to be what we're looking for, or the length of AP.